Okay, let's get back to the lesson. The previous part we talked about the area of the room. And if you want to buy an air conditioner, how do you know that you will get the right air conditioner for your room? Picking the right home air conditioner is very easy with the right information. Before buying an air conditioner, find out how many BTUs you need. So, what is BTU? BTU is British Thermal Unit. This is the unit used to measure the thermal energy or heat energy that is needed to raise the temperature 1 pound of water by 1 degree Fahrenheit. And in industry, BTUs measure the quantity of heat a conditioning unit can remove from a room per hour. 1 BTU per hour is equal to 293 watts. Then, when you want to calculate BTU, that's the following formula is needed. BTU is equal to the length times width times factors. This means you have to think of the size of the room and what the room will be used for. These factors means the environment of your room. Just like you have the bedroom, if your bedroom has no sunshine, the factor could be 750. But if your bedroom exposed to sunshine, the factor is higher. And each air conditioner is rated to produce a certain number of BTU. Then, to calculate how many BTUs you need, you can use this rule that help you get the right air conditioner and you can keep in your room cool. First of all, you have to measure your room. Multiply the length of the room by the width and then calculate the suitable BTU for your room. According to the formula from the previous slide, and sometimes you need to consider the condition of the room and adjust the value of the BTU. For example, if the room is heavily shaded, you have to reduce capacity by 10%. Or if the room is very sunny, you have to increase the capacity by 10%. In case the room has more than 2 people regularly occupied by the room, you need to add 600 BTU for each additional person. And some room has a very hot environment, just like in the kitchen, you need to increase the capacity by 4,000 BTU. Then, what is the capacity? The capacity relates to the volume. Volume is the amount of a space taken up by an object, while capacity is the measure of an object's ability to hold a substance, just like a solid, a liquid, or gas. Then you can find the volume of any solid object from the formula. The volume is equal to h times h times h. H here refers to the size of the object. Just like this cube, the bigger cube has 1 inch for each size. So this cube has the volume 1 cubic inch. And the small cube here has 1 centimeter at each side. So the volume of this cube is 1 cubic centimeter. And the symbol for the cubic look like this. This is for the cubic inch and this is for the cubic centimeters. So the volume of the object, it means the side times side times side. Since each side of the square is the same, so it can simply be the length of one side cube. How about the shape of the object that is not square? Just like this box. This box is the parallel, sorry, parallelepiped. Parallelepiped. Okay. The volume of the box is come from side by side by side as well. So this side is the length and width and height of the box. So you get the formula for any parallelepiped as V is LWH. V here stand for the volume, L for length, W for width, and H for height. Then this example, this exercise, you can find the value of each solid here. The first exercise, the volume of the first solid. This shape is a cube. So the shape of cube is side by side by side, right? Then 10 centimeters by 10 centimeters by 10 centimeters. So you get 1000 cubic centimeters. For exercise number 2, this box, the volume of this box again side by side by side. LWH, L is 11 inches times 7 inches times 3 inches. So you get 231 cubic inches. That's the simple shape. Now, let's try another exercise. Suppose you are pouring a rectangular driveway with dimensions of 24 feet by 65 feet. Okay, when you read the question or the problem, try to understand the question. Rectangular driveway. This is the rectangle shape, right? Rectangular. With dimension of 24 feet by 65 feet. Okay. The dimension. The depth of the driveway is 3 inches. The depth, 3 inches. And the concrete is ordered by the cubic yard. This is the cubic yard. How much concrete should you order? Okay. Let's define the rectangular driveway first. It's 60 feet, 65 feet by 24 feet with the depth of 3 inches. Then the volume. What is the volume of this driveway? The volume comes from side by side by side. So 65 feet by 24 feet by 3 inch. From this multiplication, you can't do it now because the unit is not the same. You have to make the unit in the same system before you do the multiplication. And how to change? In this case, we need to change from inch to foot or feet. So, as we know, 12 inches is equal to 1 foot. What if you have 3 inches? What is 3 inches in feet, in x feet? X is the unknown now. So, the x feet is 3 inches divided by 12 inches times 1. Okay. The x is equal to, now you can cancel the same term. You get 0.25 feet. Okay, you replace 3 inches by 0.25 feet. Now, you have the same unit. You can do the multiplication. Okay, the volume of this pavement of this driveway is 395 cubic feet. But the question asks you to pouring the concrete in this driveway, and you have to order in cubic yard, in the cubic yard. But now your unit is in the cubic feet. How to change this unit? How to change this to be a cubic yard? As we know, 1 yard is equal to 3 feet. Then the cubic yard mean cubic times cubic, 1 yard times 1 yard times 1 yard. This is a cubic yard. So then 1 cubic yard is equal to 27 cubic feet. Then you can get your equation as 27 cubic feet is equal to 1 yard, 1 cubic yard. Then how much? 390 cubic feet. Change it into x cubic yard. So x is equal to 390 cubic feet divided by 27 cubic feet times 1 cubic yard. And then you get 14.44 cubic yard. So this is the exactly amount that you want. But when you order, normally we have to round the number. So you can round the number. You may say you have to order the concrete around 15 cubic yard. and one of the most common applications of the volume involved in measuring the amount of liquid a container holds, which we refer to its capacity. Then, for volume, the volume is measured in cubic unit, while capacity can be measured in almost every other unit, including liters, gallon, pounds, or etc. Then you can convert between these units, just like you know that 1 liter is equal to 1000 cubic centimeters, or 1 cubic foot is around 7.48 gallons. Then let's try to find out the capacity of each container. For the first exercise, this is the fish tank. Find out how much water would this fish tank can hold. Then we are going to find the fish tank capacity, which is equal to the volume of this tank. The volume of this tank, this is the parallel pipette. So the volume is LWH, right? L is the length, 1 foot. The width, 1/2 feet. And the height is 1 foot. So you can say this fish tank capacity is 0.5 cubic feet. Exercise number 2 is orange juice box. How much the orange juice would be whole in this box? So the juice box orange juice box, orange juice box. The capacity is equal to the length of the box, which is 16 centimeters, times the width of the box, which is 10 centimeters, and the height of this box is 25 centimeters. So the product of this box is 4,000 cubic centimeters. This is the unit of this box, and this capacity can change the unit as well. Suppose you want to know that what is the capacity of this box in liter, then you can change it because you know that 1000 cubic centimeter is equal to 1 liter. So 4000 cubic centimeter is equal to 4 liters. Now let's try another exercise. This ecological swimming pool is advertised as being 20 feet by 25 feet by 5 feet. How many gallons will it hold? Okay, from this question, this value, it means the volume or the volume of the swimming pool. They ask you how many gallon, it means they ask you the capacity. Then the swimming pool capacity is from 20 feet times 25 feet times 5 feet. And you get 2,500 cubic feet. But the question asks you how many gallons. Then you have to change this cubic feet to be gallon. And from the previous slide, we know that 1 cubic foot is equal to 7.8, around 7.8 gallons. So you can make the proportional of this as 1 cubic feet is 7.8 gallon. So what is 2,500 cubic feet in gallon? Then you are going to find x, 2,500 cubic feet times 7.8 gallon divided by 1 cubic feet. Okay, then you will get x is 19,500 gallons. That's the simple exercise. But in real life, not only a square, a cube, or a box, there are many shapes like this. Just like the box, like this first one. This is the right rectangular prism. This one, the volume of this one can be calculated from BH. B here stand for, this B stand for the area or base. Base of the right rectangular prism is LH. Base here is LWH. Or this one, this right circular cylinder. The formula to find the volume is BH as well, but base for this case, it means this area. What is this area? This is the circle, the area of circle. Then the V, the base here is come from the area of circle. B here should be pi r square. Okay. Let's try to find out the volume of these solids. The first one is cylinder. The volume of the cylinders, it means the base of the cylinder times the height of the cylinders. So the base, this is the circle, right? The base is pi r square times h. What is r? The radius. This one is r. So you replace r by 6.2 centimeters square times h, which is 15 centimeters. Then the result is 1811.44 cubic centimeters. second exercise, this solid look like a prism, but the base here is the triangle. So the volume of this solid come from the base times h. This is the h, or the height of this solid. But base, the formula to find the base in case of triangle, the area is 1/2 times base of the triangle and times the height of the triangle. Okay, I think I should use this h as the capital H. Okay, then 1/2, the base is 15 centimeters and the height of the triangle is 6 centimeters. Or not centimeters, it's in the meters. Okay. 15 meters times 6 meters and times the height, which is 10 meters. Then the final result, the volume of this solid is 450 cubic meters. Now, let's try another shape. Exercise number 3 is a sphere. The volume for sphere is come from the formulas 4/3 pi r cubed. 4/3 pi, what is r? This one is r of this sphere. So 8.2 centimeters cubed. Then the final volume is 2309.56 cubic centimeters. How about this prism in exercise number 4? The volume for prism, this is the 1/3 times base times h. Okay, the base, because this is the square, right? 1/3 times 5 meters times 5 meters and times the height of this pyramid, 3 meters. Then the final result is 25 cubic meters. Okay, these are the volume and capacity of the solid. Next topic is about the money. When you want to buy something, but you don't have enough money, what should you do? You may say, oh, Ajahn, we can ask the money from our parents. Yes, but sometimes you need a big amount of money. You have to borrow from the bank or from someone else. What should we do? So we are going to talk this topic in the next part.